Hello friends, this lecture is about building envelope design for sustainable buildings. Is a very interesting topic and a very important topic in today's context, where the buildings are not only facing the challenge of being benchmarked globally about the way they look and the how and they feel, but also equally important, the way they perform. Building envelope for any building is the first phase which actually faces all the issues of climate, of the environment, and makes it more comfortable and more viable for the people to really operate the building from inside. So, let us go through this interesting topic about the building envelope. As I said, these are the main issues which are to be dealt with when we are talking about building envelope for any particular building. We are fortunate in a country like India where sun is available for 300 days, but when sun is there, it definitely brings in the daylight. With daylight, the problem of heat and glare also comes. So, it becomes important that all of these elements are looked in a holistic manner whenever we are designing any building envelope. So, what is required is to achieve a right balance to achieve visual comfort, thermal comfort, occupant health and the energy efficiency. Gone are the days that we only deal with the energy efficiency part of a building. Today, we are talking of the well-being, the comfort, the health aspect of occupants living inside the building. So, it becomes more and more important how do we tackle all these issues together. A building envelope is basically formed with elements which are captured here. One of the first is the opaque exterior construction, which means the walls that we see outside any building. Fenestration, which is the glazing part in the form of either a window or a curtain wall or a structural glazing, and the building roof, the topmost part of any building. Each one of these elements have got its own importance, the kind of materials we use, the kind of design we do for any one of them actually defines the performance of a building in a different manner. The right approach of design for a building envelope starts right from understanding the climate better. Understanding the climate is as important as taking the first step to anything. You can see a lot of old buildings, monuments, the buildings which have been constructed hundreds of years ago, they are still standing tall, mainly because they respond to climate of that particular area. The buildings were designed in a manner that they are comfortable even today, they do not really need any electricity, and the credit goes to the climate responsiveness and the kind of materials which are used in those. So, it is important element. After that, whenever the building is getting started to design, the first thing is the floor plate. How much deep should a floor plate be? And a very deep floor plate with only exterior glazing may not really give you the desired outcomes on the daylight front. Narrower building may also not fit best. So, an optimum floor depth is required when we start designing that. Optimizing the window to wall ratio is the next important step. For any facade, when we talk about the kind of materials we are going to use there, the first thing is how much of the glazing, how much of the wall area should be there. So, window to wall ratio, defining it, optimizing it is very important, because too less WWR means very less glazed areas which will not give you daylight. Excess of glazed areas means higher WWR will penalize you on the heat ingress, the energy cost of the building, the oversize of the systems, more capital cost and more operational cost if the materials are not selected properly. So, an optimization is required whenever we are talking about how much should be the glazing area, how much should be the solid area. Facade shading. So, after you have designed whatever amount of glazing, how best is that shaded? Now, in our country where a lot of heat is there outside, we have to deal with the proper shading to shade the facades and to keep the heat out. So, facade shading is the next step. Controlling glare and enhancing daylight. That's a combination which is very important when we discuss about the ingress of light, with that the ingress of heat and the glare. So, all these three elements of controlling glare, enhance daylight and control heat transfer is something which has to be taken holistically. I will show you in one of the case studies that I have how to do that, and specify building envelope properties according to that. So, where to start? The first step is to start with the basics, as I said, understanding the climate. Here you see the climatic zone map of India. India has got 5 climatic zones: hot and dry, warm and humid, composite, temperate and cold. Now, each of the climates has got its own parameters, its own climatic parameters which are important to be understood, and the building design has to come across according to that. So, when we talk about the climate and the design of the building, one important element is to combine passive with active, because it is the passive measures which actually enable you to reduce the cost of the building at the basic level itself. If the passive measures are done right, a lot of optimization happens there, low cost solutions are achieved, and you really get the desired output with a lesser capital investment. Just to give you a brief on that, this is the kind of potential which is there if we do the basic principles right, if we incorporate the passive strategies right, and if we do the selection of materials right. Around 30 to 40% savings can be achieved on the energy front if we do the basic things right, which means the right orientation of the building, right window to wall ratio, shading devices, proper selection of glass and wall construction. When you are increasing the savings, there is also a potential that you reduce your air conditioning size. While your energy consumption is linked with your operational cost, reduction in tonnage becomes your capital cost savings, and in the whole process you reduce the CO2 emissions, which is the most important environmental parameter of any building design. Buildings are responsible for around 40% of CO2 emissions globally, and if we deal with our designs properly, if we design the buildings properly, there is a huge contribution that the building sector can make on reducing the global emissions in terms of the CO2. In India, we also have got the Energy Conservation Building Code. Now, ECBC 2017 provides the norms for building envelope also. In many states, it is becoming mandatory now to follow ECBC and implement in the projects, and the requirements that are supposed to be achieved for different elements of the building envelope, including roof, walls, fenestration, all of that is laid out there. It is important in the process to really refer to it and abide by it. What this ECBC 2017 is also doing is providing some guidelines on how to really get into the building envelope design, which comes as very handy for many people. So, it is definitely a good step to refer. Now, I will take you to the case study, which is for an office building. It is an office building located in NCR. Now, as I said, the buildings with more and more emphasis on the aesthetics of the building, we intend to go with more glass. Going with more glass is not a problem, but optimizing it to the best possible manner is something which is required. In this particular case, the building's design started with a window to wall ratio of 80%. Now, this analysis was done actually at the right concept stage to analyze what happens if we change this WWR from 80% to something else, or what should be that optimum WWR that we should be achieving in a design to make it a high performance building. Now, it is a very important step and also very motivating right at the concept stage, because that is where you end up doing the best design. If your window to wall ratios are optimized at that level, it is something which you can enjoy throughout the project. In this case particularly, what we did was the analysis done for seeing really how much effect of changing the WWR happens on the energy front, energy consumption of the building, and how much impact of that comes on the AC sizing of the building. With this analysis, we found that the WWR of 30% is going to give the best effect in terms of energy savings, and also AC loads can be reduced by around 15 to 20%. This analysis is about fenestration's shading coefficient. How much shading coefficient should we go for? Again, the similar analysis on energy and chiller tonnage, and what was identified that a shading coefficient of 30% can be a good shading coefficient to look at in terms of optimizing the building performance. Then we did the daylight analysis to identify how much effect of different WWRs is going to be there on the daylight harness in the building. And daylight, to me, it is very important because with the best utilization of daylight, we can reduce our lighting consumption, which is a win-win in every sense. And daylight has been, there has been many studies which have proved that daylight is something which has got a lot of positive impacts on the people's health, their comfort. So, if in a place you are able to utilize daylight in a best possible manner, it's serving all the purposes of efficiency, health and comfort. So, that is an important area to look at. In this case, we looked at how much daylight do we achieve if the WWR was kept at the design case, and the kind of glazing we select. So, visible light transmittance of 40%, which is a property of a glass, if we choose that, how much is going to be the daylight? If I increase my VLT by 10%, at 50%, how will it perform? At 60% VLT and at 70% VLT. So, different, you can actually choose the glazing type based on the analysis rather than the guesstimates. In this case, what we found was that you will see these three columns here, which defines underlit areas, compliant areas and overlit areas. Now, this is that zone which is more like a usable daylight. If you have lesser lux levels than what is required, the area is going to be dark and you are going to switch on the light. If you have overlit spaces, means you have got more daylight than what you need, you are probably going to use blinds to get that daylight out, and again you are going to use your artificial lights. In many cases, we have seen this as a problem. Glazing our design without really looking at the overlit spaces or the glare aspect, and we end up seeing situations where even if there is a glazing, we are not able to use the daylight. So, usable daylight is something which is what we are looking at. In these four cases, the usable daylight areas were coming out to be 60%, 81%, 94% and 87%. Now, the target we were setting for ourselves in this particular case was around 90%. So, that is something we get with 60% VLT and 70% VLT, and this was something which is more closer to our target, in fact better than the target. So, we can go with this glass, but after that we also studied how much is my direct solar ingress going to come with the kind of glazing I have. If I have no shades, this is the glare analysis where all the white patches that we see are glare. It is done for 3 different seasons: summer, equinox and winter solstice. And what we found with this solar ingress analysis was that there is an acute glare which comes from south and west facades. So, if people are really sitting over there, they might not be comfortable, they may be using blinds, and the whole concept of the high performance building may go off. So, there has to be glare mitigation which needs to be adopted. Then we also took a deep dive to understand how much is a problem, for how long is a problem in terms of glare, to design the building in accordance with that. And from the south facade, what was identified, for all 12 months, we identified the glare timings, and what was good to see was that from May to August there was actually no glare that was observed, but there was a lot of glare in the other months. So, there is about 8 to 9 hours where we were facing the problem of glare. Then we started developing the options, what could be the glare mitigation strategies, and we worked out there are 7 options in this case of different types, where we have got horizontal overhangs of different sizes, of different numbers, spacing between them, angular ones, and different combinations were worked out. And for each one of that, we really analyzed how much effect do we get. So, with first strategy, the results were okay, but not very significant. Then we started analyzing the other ones, and results kept improving, and we could actually eliminate the glare during entire summer and mid seasons with these strategies. Only for the winter season there was slight glare which was left because of the lower sun angles. We did the similar exercise for west facade also. There was about 5 to 6 hours glare from the west side for almost entire year, which is critical to deal. And we did the similar exercise of optimizing the facade from the glare mitigation point of view. Different options of shading were proposed there, and it actually got mitigated for almost all the months except for the winter season, again because of lower sun angles. But that is something which, rather than overshading, it is better to use a different approach for only those very critical times. Then with the shading devices, what happens is that our daylight also get affected. So, we did the daylight analysis again to see how much is the effect on the daylight that we are getting because of shades. So, in this particular case, our compliant areas were actually coming out to be 97%, because the shading was optimum. But we started working on even the WWR, because the WWR was high. We intend to even reduce that, so that our energy consumption can also be controlled. We reduced the WWR to 40%, which is what even the different standards ask for, and saw there is a decline in the usable daylight areas from 97 to 69%. We then, to compensate that, we can go with a higher VLT glass, and with that higher VLT, shading and optimized WWR, which serves all the purposes, we are at 90% daylight areas. Even the energy use optimization study we did, and found that by doing different strategies, we were able to actually get all these outcomes of over 90% areas with daylight with minimum amount of glare. Energy savings were achieved for about 15%, and visual comfort, thermal comfort, all the targets are achieved. This is another case study where it's a commercial office building coming up at Noida. It's a very interesting building where the envelope optimization has been dealt with very carefully, and it's a very ambitious building which is coming up. And what are the basic outcomes? If you really see here, you've got 360-degree daylight in all the areas. The entire building is daylit adequately. You've got very comfortable daylight levels inside the building with absolutely no glare. So, the facade that you see, this is all screens. It's a dual skin facade, and there's a as high as 40% load reduction which was achieved only by envelope. Over 30% energy savings. Renewable energy is getting integrated, and the target rating over there is of course platinum. Some of the very good features which have been incorporated in this building, it's a courtyard planning. There is a central courtyard which works like a daylight well also, and a ventilation shaft also. So, it's something which is as a passive measure which has been incorporated in the building. Dual skin facade. So, there is a glass facade. Outer facade is basically a screen which is a specially designed anti-glare screen. A lot of focus was given to have the glare free daylight. So, light shelves are also designed on one of the sides of the internal courtyard. So, there was glare coming from one side of the courtyard, which is what has been optimized by using light shelves. It also helps in increasing the daylight levels for that particular area, because the light is reflected deeper into the floor plate. Insulated exterior walls, double glazing units, insulated roof with reflective surface. Now, in this particular case, I would also like to add is basically when we were doing all that optimization about the window to wall ratio and the shading coefficients and everything, as I showed earlier, we went with a higher WWR, but we shaded the entire facade. Still, views are not that compromised because there are deep balconies provided between the two skins, which have got the vegetation, which works like providing oxygen into the environment inside the building. So, it's quite a different feel from the inside, where not only the heat ingress is taken care of, but also the health and comfort aspects of the people have been dealt properly. These are the building is under construction. These are some actual photographs which you can see how this is coming up, and it's going to be really a good building in terms of really seeing how the building envelope can be optimized. And you will see on this facade there are a few areas which are like more recessed areas with no screens in front. So, the glass selection was done accordingly. It is not just one type of glass which is used, there are multiple types of glasses used on the glazing, so that we are thoughtful about where to go higher, where to go lesser, where VLT is higher, where shading coefficient is lesser. So, all of that combination has been used to arrive at the very optimum design that we have. Beyond that, there are many facades for future also, the concept which are going on. Facades generating power is definitely something which is a concept coming up, where we use the facade to generate electricity. So, we are designing net zero buildings where the solar panels are integrated onto facade, because roof areas are getting minimized, especially when you go taller in any building. So, there the opportunity becomes to generate power on the facade, and the building envelope integration with solar panels gives you the opportunity to use the panels to your best advantage of having the daylight optimization, the heat ingress, the glare, and also the energy generation. There is a concept of living facades where the greenery is being used on the facade, green walls are used. Dual skin facades, we already have one example we saw in the last case study. There is also a concept of within the dual skin facades you ventilate it so that the heat ingress is minimized through the second skin. Facades enhancing in indoor environment, growing fresh air. Facades addressing food crisis, which is through hydroponics. So, a lot of these concepts are actually very much prevalent in the buildings that are coming up and are going to come up in future. We have to be thoughtful and mindful of the fact what do we want to achieve out of the building envelope and how do we best optimize the performance. There can't be one size fit all approach because every building has got its own dynamics. Its location is different, its size is different, scale is different, usage is different, occupancy patterns are different, maybe even the schedule of operations is different. So, it has to be taken into a more customized manner. What do we design for a particular building depending on all of those factors. There are many tools available which can really give us the desired outputs and tell us, work like a design guidelines or design tools for us to give us the right figures and numbers to tell us what is right, what is not right. It's better to make use of the tools. No more thumb rules or guesstimates are required because those tools are there. It's better to utilize that. And I think more and more of the building efficiency and the other dimensions which are coming up now about the well-being and comfort and health of people, those have to be integrated along with energy efficiency. That's it. Thank you.